Welcome to today's physical science lesson. My name is Mashudu Mambur. This lesson is brought to you by the Free State Department of Education in collaboration with Pagama Research. Thank you very much. We'll be revising paper 2. As indicated, Mashudu is my name. I hope we'll enjoy paper 2. This is the structure of the paper for paper 2. Remember, paper 2 is out of 150 marks, where we have 10 multiple choice questions, and the 20 marks are allocated to multiple choice. So ensure that you get those 20 marks. Now, in section B, which are your structured question, long questions, you have 130 marks. So the total for the paper is 150 for physical sciences, and the duration is 3 hours. So as you prepare yourself, you prepare for that. Now, let's look at what you have done in terms of term 1 and term 2. You have covered under paper 2, the nomenclature, the physical properties, the organic reactions. All these are part of organic molecules. So the first part of our revision will focus on organic chemistry. You will know organic chemistry, end of the year, you are expecting about 58 marks that come, plus or minus 58 marks that comes from organic chemistry. So it's a lot of marks. And you are saying you must be able to do very well here. And if you do well in this part, you will be able to pass the paper. Now, as we move, we are saying as well, you have done the rate of reactions, you have done chemical equilibrium, you have done acids and bases, even in grade 11 as well, you have done acids and bases. So these are the topics that you are going to focus on for this revision session. I'm hoping we'll give you all the skills so that you are more comfortable to go and write and pass the paper. So we are saying under organic molecules, we'll be focusing on homologous theories. We'll start with the definitions. Remember, definitions are very much important, and we are emphasizing that all our definitions must be according to the exam guideline. We will as well look at IUPAC naming. We'll look at the physical properties. Remember, you do 3 physical properties in grade 12 physical sciences. You do your melting point, your boiling point, and your vapor pressure. So we'll focus on that. We'll look at the reactions of organic molecules. So that is the first focus of our session. And then the second part, we'll be looking at chemical change. Under the knowledge area chemical change, we'll be dealing with rates of reactions. We'll be dealing with chemical equilibrium. So those as well as acids and bases. So under chemical change, we have those 3 topics that we will be focusing on. Under matter and materials, we have organic molecules, and we are saying our organic molecules have nomenclature, which is your naming. And then we are saying the next question is physical properties, then is reactions of organic molecules. So that is our topics. That will be the focus of this session, and hoping that you have your pen and paper where you will take some of notes, but mostly we'll be focusing on exam tips to say what do you do in order to get these marks. We're saying all topics are examinable in terms of multiple choice. You'll get all those questions under materials, and then under chemical change you will get those questions, and you know your multiple choice has 2 marks, and you must be able to identify which topic does the question belong. If you have checked the structure of the end of the year paper, you will have seen that 1.1, 1.2, 1.3 is mostly organic chemistry questions. So you must be able to check. When you find a question, you will say, where is this question coming from? So you are able to know that this topic is organic molecules, so that when you respond, you are able to respond correctly. And we are saying thoroughly analyze the question before attempting to choose. Remember, we are saying you are given 4 options here. You are having A, B, C, and D. So you have 25% chances of getting a correct answer. So what you have to do, we'll advise you to say, ensure that you first remove 2 distractors. So you have 2 questions that are completely, 2 answers that are completely wrong. So ensure that you are able to remove those which are completely wrong. Then you remain with 2 options. Out of the 2, at least you will be having 50% chances of getting the correct answer. And we are saying do not skip any question. So we are saying don't leave any multiple choice question unanswered. Ensure that all your multiple choice questions have been answered. So no skipping of questions. If you have 1.1 to 1.10, ensure that when you leave the exam room, you have responded to 1.1 to 1.10. And we are saying because each multiple choice question has 2 marks, you're going to spend at least 2 minutes there. Ensure that you are doing that, and you give multiple choice most of your attention, and it will help you to pass. Now, as we start with the topic, you will remember that as far as this organic chemistry is concerned, for grade 12, we are dealing with 9 homologous series. So we have 9 homologous series, which are, I will say, is AAA, is your Higg, is your A and C, which is now the 9 homologous series. So our focus is on the 9 homologous series. We're saying this 9 homologous series, which is your alkanes, your alkenes, your alkynes, which is your haloalkanes, your aldehyde, your ketones, your esters, your alcohol, and your carboxylic acid. So those are the 9 homologous series. And you must be able to understand that these homologous series, each homologous series has its own general formula. For example, for alkanes, we are saying the general formula is CnH2n plus 2. So you will see that CnH2n plus 2 is the general formula for all alkanes. As long as you fall under alkanes, the general formula is the same. Now, and we're indicating that when you look at alkanes, you will see that all of them, they just have carbon-carbon and carbon-hydrogen single bonds. There are no double bonds. There are no any other extra atom. Hence, we refer to them as hydrocarbons because they are made up of hydrogens and carbons only. And we are saying, example there, we can have ethane. You know that if we say draw the structure, you will know that this is the structure of your alkanes. Now, when it comes to alkenes, we are saying it has a carbon-carbon double bond. The alkenes, they have carbon-carbon double bonds, and then the general formula now is CnH2n. Remember, when you bring a double bond, you remove 2 hydrogens. Hence, the general formula of alkanes was CnH2n plus 2. But when you move to alkenes, you are going to remove 2 hydrogens. Then it becomes CnH2n. So you have to have that understanding to say, as we increase the number of bonds between carbon atoms, we are going to remove 2 hydrogens. So hence alkynes, you will see that alkynes again, we're going to remove further 2 hydrogens as well. So to get that, then the general formula will become CnH2n minus 2. So you can see as we move from alkanes to alkynes, we are removing 2 hydrogens as we move like that. So you've got to understand all these 3, we refer to them as hydrocarbons because they are made up of hydrogens and carbons only. So you have to always remember that the first 3, which is our AAA, are our hydrocarbons. And then these hydrocarbons, we are saying that they are hydrocarbons. Some are saturated, some are unsaturated. Now, the saturated ones are these alkanes. They are saturated. Why do we say they are saturated? Because they have no multiple bonds between carbon atoms. So those are things that we have done. As we are revising now, you will be remembering that these ones, they only have single bonds. The S there for single bonds between carbon atoms. So it's only single bonds. There are no double bonds for between the carbon atoms. Hence, we are saying saturated. The unsaturated, it means have multiple bonds between carbon atoms. Remember, I emphasize that always remember the exam guideline as you define, because you can get a question. The first definition I gave you now was a hydrocarbon, where I said hydrocarbons are made up of hydrogens and carbons only. Please always emphasize the only part, because if you say hydrocarbons are made up of hydrogens and carbons and you don't talk about or you don't say only, your answer will have been wrong. So you have to understand that the hydrocarbons is 3 of them is alkanes and alkynes. As we move like that, we'll be doing more of the activities instead of me now maybe explaining a lot here. We move to haloalkanes. From the word halo is from halogen, which is your group 17 or group 7 elements in your periodic table. Hence, we are saying haloalkanes. Another name, we call them alkyl halides. You will see them, they will have a halogen. So you just go to the structure, to the general formula of alkanes. Remember, we said alkanes is CnH2n plus 2. Now, to put a halo in the alkane, you have to we have to substitute one hydrogen with a halogen. That's why we're calling it haloalkanes. So the X there. So you have to know that those are haloalkanes. And then that's the structure that we are having. You can see we have chloroethane given there. It's chloroethane because it's 2 carbons. Alcohols, you will have seen that alcohols, now the general formula becomes CnH2n plus 1OH. Please don't forget these general formulas, because some of the questions will ask you based on the general formulas. And you have to know as well that these alcohol is the OH group there bonded to carbon. That gives us a hydroxyl group. So you will refer, the name of this will be hydroxyl group. So this one has a name. The name of the alcohol functional group is called hydroxyl group. So don't forget, because some of the time we'll ask you a question to say what is the name of the functional group for alcohol. So you got to know that that is hydroxyl group. And then example given there, we're having ethanol as our example. Now, as we move, now I like these last four ones, because if you look at all these other last four functional groups, all of them have a C double bond O, C double bond O. If you look at them, all of them, they have that in common. The difference is that for aldehydes, it's a C double bond O bonded to hydrogen. For ketones, is C double bond O bonded to two carbons. So for ketones, it must have two carbons, but for aldehydes, there must be a hydrogen. That is to be the difference between the two. And if you check between carboxylic acid and ester, these are the only two homologous series that we do that have two oxygens. So when you see two oxygens, you know it's either an ester or a carboxylic acid. So don't forget that, so that you are able to move. Carboxylic acid, you will see it gives you that COO there. I will refer that as a COO, which is COOH. Don't forget, at the beginning of the structure, in carbon number 1, you will find that we have the COOH in carbon number 1. Then you know for an ester, the two oxygens are within the structure. It means they are mixed in with the carbon. So you are able to see that this is a carboxylic acid, this is an ester. And if you look at aldehydes, their general formula is CnH2nO. Same as ketones. Hence, you will see when you do the isomers, you will say these two are functional isomers. The same when you talk to carboxylic acid and esters, they have general formula CnH2nO2. So you got to always remember that these ones, they have the same general formula. These ones are isomer, and we call them functional isomers. You will remember that functional isomers, they have the same molecular formula but different functional group, because the functional group there, where you can see that we're having different functional groups referring to those. So when it comes to functional isomers, we are saying that you got to always remember that we are having our carboxylic acid, we are having aldehyde. So I just say cake so that you don't forget. Cake stands for carboxylic acid and ester. Those two are functional isomers. And then if you look to aldehyde and ketone, that will remind you that aldehyde and ketones they are functional isomers as well. So I hope that helps you as we move now, and we're going to look at naming. How do you name organic molecules, so that you don't have to forget this naming, because it's very much important. There are only three parts that we look at as we name. It is the prefix. In the prefix, we are going to have our substituent is our prefix. That is how the name starts. Like preschool is before school. So prefix is before the name. Before the name, you have the prefix, which is our substituent. And for our syllabus, in terms of physical science, you will see that we are having our methyl group and our ethyl group as the substituents. We are having as well our chloro, the group 17 elements, our chloro, our bromo. Those ones are our prefix. They will be at the beginning of the name. So it means, as always, when you are naming, as long as you have these four, only for these four. Last year we had fluoro, and then we still have group 17 iodo as well. So it's good that you must always know them as well, those four group 17 elements, to say for these ones, they are referred to as substituent. They must be at the beginning of the name. I hope you get that we have those as our substituent, which will be at the beginning of the name. And then the parent. For the parent, we are looking at the longest carbon chain. So you'll be looking to say, how many carbons do we have in the longest carbon chain? Then that will give you, for example, we're going to look at it to say, okay, if we have, I usually will say map BP H, or so that you don't forget to say, if we have one carbon, you will remember it's meth. If we have two carbons, is eth. If we have three carbon, is prop. If we have four carbons, is put. If we have five carbons, pent. Hex for 6 carbons, and then hept, hex for 6 carbons, and hept for 7 carbons. So 7 carbons is hept, and 8 carbons is oct. I think I have that in the next slide that is coming. But I felt that it's important that you don't forget how do we determine the parent. You see, the parent, you are looking at the longest carbon chain. Then you check how many carbons do we have on the longest carbon chain, and then it will tell you the name. The suffix, we are looking at the functional group to say what is the functional group. The functional group that gives us the homologous series. So we're able to get the suffix, which is how the name will end. Now, with no wasting of time, we're going to move now to do an activity to say, look at question 1. It's saying which one of the following is a general formula. You'll remember in my introduction, I've taken you through that table of functional groups and their general formulas as well. So we're saying which one is the general formula of alkanes. Don't forget, we said for alkanes is CnH2n plus 2. We said for alkenes, we remove 2 hydrogens. So this one, CnH2n, will be for alkenes. So it's not for alkane, it's for alkenes. CnH2n minus 2, we said is for alkynes. So don't forget, because as you write your exams, there will be one of those. So you have to know all of them. But for alkanes, is CnH2n plus 2, which is this one. So you are able to choose your answer. You simply write question 1 is C, then you get your 2 marks. And if you can look, the ones that we're having is those ones. This one for alcohol is supposed to be CnH2n plus 1 OH, then it will be correct for alcohols. But this question was about alkanes. So for alkanes is CnH2n plus 2. So you're able to choose number C. So you see the importance of understanding the general formula as you are revising. Ensure that you know for all the 9 homologous series, you know the general formulas. Now, as we move, the statement says, consider the following statement regarding the compounds in the same homologous series. So they belong to the same homologous series. Remember what I said? I said that if they belong to the same homologous series, it means they have the same general formula. Remember the definition of homologous series, which says that homologous series is the series of organic molecules that is described by the same general formula. So they're described by the same general formula. So don't forget that the homologous series are described by the same general formula, and each member differs from the next by CH2. For example, if I was to write CH4 and write CH3, and write CH3, CH2, CH3, you will see that the difference between all of these is a CH2. Even you check here, the difference between this one and this one will be CH2. So you got to know that, okay, the homologous series by definition, they have the same general formula, and each member differs from the next by CH2. Now, let's look at the statement. Which one is correct? They are saying they have the same boiling point. If you can look at my methane, ethane, and propane there, they cannot have the same boiling point because their chain length are not always the same. So remaining figure 1 is wrong. So you know that cannot be correct, because not all organic molecules that are in the same homologous series have the same boiling point. Remaining figure 2 is saying they have the same functional group. Yes, remember how you differentiate between the homologous series? We said we do 9 of them. The difference between them, it is the homologous series. So it is the functional group. So the functional group is specific, and all the homologous series that belong, because it's like a family, in the same family, you have the same functional group. So this is correct, that all homologous series have the same functional group. And then they have the same molecular formula. Note molecular formula. What is the same is the general formula. So you got to know that this is wrong. Then when you go to the options, you are able to see that option number A is your correct answer, because you have you are saying the homologous series have the same functional group. If you are talking about alkenes, they all have the same functional group, which is carbon-carbon double bond. Alkynes, carbon-carbon triple bond. And then if you are talking about aldehyde, it's a C double bond O and an H there. A ketone is a C double bond O surrounded by 2 carbons. So you are able to remember all these functional groups and know that as long as it's the same homologous series, they must have the same functional group. I think I've emphasized that, and you won't forget as you prepare for your exams. Now we are saying, look at this question saying name of the functional group of alcohols. As I was doing the table there, of functional group of homologous series. I've indicated to you to say you must know the names of these functional groups. Carboxyl group, you know, is the name given to carboxylic acids. Carboxylic acids, their functional group is called carboxyl group. And then you are having the carbonyl group. Carbonyl group is for ketones. So you got to know for each of these. So I'm happy because this slide is teaching you the names of the functional groups so that you don't forget these names. To say for carbonyl is for ketones, and formyl group is for aldehydes. You're only left with hydroxyl group, which is for alcohol. So you know that your answer is D. You see, as I try to answer questions, I go through all of them because I have 2 minutes to spend on a multiple choice question. So I might as well look at all the options and be able to know why I'm saying A is wrong, B is wrong, C is wrong. I'm 100% that D is correct, is the functional group of alcohol, is the hydroxyl group. And the other thing which is important, you can see that these names of functional group, they always go with group, and they all end with the il there. So you are able to remember that. So we're saying for carboxylic acid is carboxyl group, for ketones is carbonyl group, for aldehydes is formyl group, and for alcohols is hydroxyl group. So please don't forget this all the time. Always remember this information. It will help you as and when you prepare yourself. Now, which one of the following compound is an aldehyde? Remember, aldehyde is a homologous series, and the homologous series, we use it for suffix, name ending. Remember, we're saying suffix is name ending, to say how will the name end. For aldehyde, the name end with the al. So you know that al, the one that will end with the al, is the one that is aldehyde. So you're able to see that this end with an al. So number A is my correct answer. So I'm able to choose that. But as well, check to say the all stand for which one. The all now represent alcohol. Remember, from alcohol, we're taking the all there to say all is for alcohol. So you are able to know that the suffix is determined by the homologous series, which depends on the functional group. The own, if you look, functional group with the own is ketone. So when you see the own, you know those are ketones. And then the alkanoid, you have the OH there. The OH there, you must know when you have OH, you have esters. And I must remind you how these esters are formed, because we're saying our esters are formed between an alcohol and a carboxylic acid. And you got to always know that the alkyl group, this one, is from the alcohol, which was ethanol. And then the OH is from the carboxylic acid, which in this case will have been propanoic acid. So we had propanoic acid and ethanol. When we mix them together in the presence of, remember, esterification happens in the presence of a catalyst, and our catalyst is sulfuric acid. So you have sulfuric acid there, then you are able to form ethyl propanoid plus water. Remember, we are removing the OH from there and the H from the acid to form water. So it will form ethyl propanoid plus water. So I'm happy because this slide was able as well to remind you of the process of esterification. So sometimes we can get so many marks from here where we'll say draw the structural formulas of ethanol. You draw the structural formula of propanoic acid. You draw the structural formula of ethyl propanoid and water. Remember, when you say structural formula of water, you must draw the structural formula of water correctly as like that. You can't draw water as a straight line like that. No, it must be bent like that. So we'll be able to know that it's angular as it appears there. So if you are saying write down the structural formula of water, you got to know that that is how you'll write it. If you say ethyl propanoid, you are able to draw the entire structure. Remember, what will help you in drawing the structural formula is the issue of looking at eth. To say eth is two carbons. So you know that you have 2 carbons bonded to one another, and the all, you know, is from the OH, the alcohol. So you put the OH there. Then you know that is your ethanol. That's how you will draw your ethanol. Propan, we said prop is 3 carbons. Don't forget, prop stands for 3 carbons, so you're able to draw 3 carbons. Oic acid is from the carboxylic acid, which you said the name will end with the Cu there, the C double bond O and the OH. So you're able to see that the carbon number 1 will have COOH there, like that. Then ensure that each carbon all the time is surrounded by 4 bonds. There must be 4 bonds around each carbon. Always count the number of bonds around the carbon, because if they are less or more, the whole structure becomes wrong. So please, you are able to do that. We said you are going to remove the OH there, and that H, then you join the 2. The O there will join with that one to form ethyl propanoid. So I was able to show you esterification as well because of this question. Now let's look at these ones, which say which one of the following compound is a carboxylic acid. So carboxylic acid, you know that the C, if it's like that, the best way to deal with this type of question, draw the structure, draw structural formula so that you are able to see it clearly. Because when it's like that, you might not be able to see what's happening. But immediately when you write a carbon with 3 hydrogens like that, you are able to see that this is my CH3. You are able now to say this is C, and then we are having O, and then we are having CH3. So you can see that there must be 1, 2 bonds on this carbon, which means that the O has double bond there. Then it's a C double bond O. Then you know that this is a what? It's a ketone. So it's important that you know how to draw these structural formulas, because they will help you. As you see that CHO there at the end there, you are able to say, okay, we're having 3 carbons. This one is a CH3. You draw CH3 there. It's a CH2. And then you are able as well to go and draw the C and then the H. You see that this carbon has 2 bonds. So it means the oxygen has a double bond O. Then you are able to write that. That is a C double bond O. So you are able to find all these structures with no problem as and when you have to draw. And you are able to see that, the C double bond O now, this one is no longer a ketone. It's now an aldehyde. And we're saying aldehyde differs with the ketone, because for the ketone, the C double bond O is surrounded by 2 carbons. For the aldehyde, we are saying the C double bond O is having hydrogen at carbon number 1. So you see, and these 2, I already said to yourself, to say these are functional isomers. They have the same molecular formula, but different functional groups. Now, the question was, which one is a carboxylic acid? So you're able to see that it has that Cu, the carboxylic acid, the COOH. Remember we said we only have 2 homologous series of the 9 that we do in grade 12. We only have 2 that have 2 oxygens. So immediately when you see 2 oxygen, you know it's either an ester or a carboxylic acid. But for an ester, the oxygen must be surrounded by carbons. There must be carbons both sides of on the sides of the oxygens. So on this one, you are able to see that it's at the carbon number 1. The Cu is in carbon number 1, so it's a carboxylic acid. Then you are able to know that the correct answer is number C. I hope these questions are helping you to understand and to move as you revise and prepare yourself. Which one of the following pairs of compounds are functional isomers? So now we are looking at functional isomers to say which ones are functional isomers. Remember, I said already that it's a cake. When you think about functional isomers, we are saying it's a carboxylic acid and an ester, it's an aldehyde and a ketone. So all that is able to help you to remember that, okay, let's check. These are functional isomers. They are here on the cake. If it's not here, it's not part. So you can see this is an alcohol. We don't have an alcohol in functional isomers. We have an aldehyde, but not an alcohol. So this makes this wrong. We have a butane. It's an alkane. We don't have alkanes. And this one, you can see that this one and these two, butane and 2-methyl propane, these are chain isomers. They are chain isomers because you can see they all have 4 carbons. So they have the same molecular formula, but different types of chain. This one is branched, this one is unbranched. So you're able to see that these are chain isomers. When you look at this, propan 1 all and propan 2 all, what is changing is the position of the hydroxyl group or the alcohol there. The hydroxyl group is in carbon number 1, the hydroxyl group is in carbon number 2. So this will tell you that these are positional isomers. So we're able to look at all. This is positional isomer. So these are positional isomers. So you're able to remember positional isomer. So you can see we have no any other choice. We are having here a carboxylic acid, our C, and an ester here, or C like that in our cake. We know that a carboxylic acid and an ester are functional isomers, and aldehyde and the ketone are functional isomers. So you are able to know that your answer there is number D, and then you are able to move. Now let's look at esterification. I'm happy because already I've shown you this type of question to say we have the alcohol part, we are having the carboxylic acid part. So you can see that already the part that has the C double bond O, the OH part, is this one with the C double bond O. This one, they all come from carboxylic acid. This comes from carboxylic acid. And we are having this one, which is our propyl. Propyl will come from propanol, which is an alcohol. So we have propanol, we have ethanoate. Ethanoate. So you are able to see that this is where it's coming from. This is one is coming from ethanoic acid. Ethanoic acid. So the acid is ethanoic acid. And then the propyl, this one we call it propyl, is coming from the alcohol. So always know which part comes from which one. Now, when you look at the question saying which one of the following pairs of reactants can be used to prepare this compound in the laboratory. So obviously you need propanol and ethanoic acid. Propanol and ethanoic acid. So if you check there, you are having propanoic acid, or it must be ethanoic and ethanol, which is wrong. Propanoic acid and methanol. As long as it's saying propanoic acid, you know it's wrong, because on this part we want the propanol. So it's propanol and ethanoic acid, which is option number C. So be careful not to be in a hurry to answer the question, because you'll end up answering a wrong question. I hope this helps you as you move. Now, we're saying which one of the following is the empirical formula of 1,2 dichloroethane. 1,2 dichloroethane. Now you have to first know what is 1,2 dichloroethane, because ethane, you know, is 2 carbons, and then we're saying in carbon number 1 we have a chloro, in carbon number 2 we have a chloro. That is 1,2. Then you have to complete your structure by indicating those hydrogens there. Then when we talk about empirical formula, we're talking about the simplest formula that you will get. It means it's like you are dividing this by 2. So if you were to divide this, you can see what we're having here is 2 carbons, is C2, H4, Cl2. If you were to divide it by 2, you will have 1 C, you will have 2 hydrogens, you will have 1 Cl, which is number B there. Then you're able to see that, oh, that is the empirical formula, because that is the simplest. It means you cannot be able to divide this further by any 2 or any other number. You cannot divide it, because that is the empirical formula that we're having. So you are able to choose number B as your empirical formula, and you are able to look at that. Now let's look at naming of organic molecules. As we complete now the part of naming organic molecules, we're saying which one of the following is the IUPAC name of this compound. Remember, we said three steps that you must follow. You are looking at the prefix, that is the substituent. You are looking at the parent. You are looking at the suffix. Remember, for suffix, we said is the functional group that is being determined by what? By the homologous series. So the name ending, how the name will end, it will depend on that suffix. The parent was saying how many carbons in the longest carbon chain. How many carbons in the longest carbon chain. The prefix was saying, do we have substituents? Remember our substituents? We said it's your methyl, it's your ethyl, it's your bromo, it's your chloro, even further fluoro and iodo, if I'm to include those based on last year's paper. Now, if we look, let's start from the suffix at the end, name ending. Name ending depends on the functional group. So identify the functional group. That is a coup there. So a coup, you know, is an oic acid. That is an oic acid. You know that it's a name will end with oic acid, because this is a carboxylic acid. It's a carboxylic acid. So it's an oic acid. Then we go to the parent to say how many carbons do we have in the longest carbon chain. So if you are counting, you cannot say 1, 2, 3. No, you must continue to say, okay, carbon number 1 is this one, because it has the functional group, and the functional group always gets the preference. So this is carbon number 1, carbon number 2. But if you go that side, you will have left all these other structures. So you have to continue to say this is carbon number 3. Now for carbon number 4, it doesn't matter. It can be this carbon or this carbon. It's up to you. So I'm choosing to take that as carbon number 4. So I know that 4 is but. Remember, you can't come here and say but. You will say butan. You only use the but, the meth, eth, prop, but you use that for usually for hydrocarbons. Yes, it will work when you're dealing with methane, when you're dealing with ethanes and all that. But when it comes to other homologous acids, more especially the last 5, which is your aldehyde, your ketones, your esters, your carboxylic acid, you have to write butan. You only remove the e, then it will be butan. Then when combine them, it will be butanoic acid. Now you look at for the substituents to say in carbon number 2 we have a methyl and another methyl. In carbon number 3 we have another methyl. So we have 2,2 because here don't forget the two numbers, you put a comma between them. 2,2, 3. So that will be your name. 2,2, 3. Don't forget the numbers between them is a comma, but between an alphabet and a number, you will put a hyphen. Then you put your hyphen there to say this is 2,2, 3 because there are 3 of them. Is try what? Try what? Methyl. What is the parent? Butanoic acid. So you are able to see that this is 2,2, 3. 2,2, 3 trimethyl butanoic acid. 2,2, 3 trimethyl butanoic acid. So you're able to name that structure. I hope you'll enjoy your naming. Name as many structures as you can. I'll just do maybe number 8. Then we're able to move with to other types of questions. I think we've done justice in terms of this because this is your foundation in terms of organic. It's important that you collect all the marks. We're saying write down IUPAC names of the following. So the same principle applies. You can see that we don't have any other functional group. So that is your AIN. Name ending will be your AIN. And if you look there, the longest carbon chain will be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So there are 6. So that is hex. So you know the parent is hex. The suffix is AIN. Now you look for the substituents. Where do we find substituents? It's very much important that you look at the issue of numbering because there is a competition between this carbon and this carbon to be carbon number 1. So if you look in all of these two, this one is saying I'm carbon number 1, I'm carbon number 1. But if you move to carbon number 2, all of them, they have a chloro. They have a chloro. So the competition is still a draw there. But when we move to carbon number 3, the one that becomes carbon number 3 will be this one because it has a substituent. This one won't be carbon number 3 because it has no substituent. So you will number from the most substituted side. The side that is having many substituents, you will number from that side, which means this is carbon number 1, number 2, number 3, 4, 5, 6. You got it. You know it's hexane. Then you're just checking that in carbon number 2 we have a chloro. In carbon number 5 we have a chloro. So it's 2,5 dichloro, 2,5 dichloro. And then in carbon number 3, you have a methyl. Don't forget those hyphens and those commas. You must use them and use them correctly. Remember, it's only carboxylic acid and esters that have 2 names. The rest of organic molecules, when you write, no matter how long the name is, it will be 1 name. And then if you look at number B, we have talked about this already. It's a carboxylic acid. 1, 2, 3, 4. It has 4 carbons. So that is butanoic acid. So that we are able to move forward. So I hope in terms of naming of organic molecules, you will do well there. In terms of isomers, you will do well. We're able to cover that. And I hope you are fine and you are ready as far as that one is concerned. Now, let's move to physical properties. Remember, when it comes to physical properties, we're only doing 3 physical properties in terms of grade 12. So our focus is the melting point, the boiling point, and the vapor pressure. Now, I always want to put them in order to say, okay, what comes first? Let's say you are having ice. Ice is solid. So when you are having ice, it's your solid. You can melt it. Then it becomes liquid. Then if you continue to heat the liquid, it will boil. Then it will become what? A gas. But now we can see that melting point, the first thing that will happen is the melting point. But now before the water boils, it must vaporize first. There must be vapor first. So it means it's melting point, then is vapor pressure, then is boiling point, so that we have a good understanding of how this is working. So if you are having your water, your ice, you melt it when you increase energy or when you increase heat, you will melt it, then will reach what is called the melting point. And we are saying melting point is a temperature. Don't forget these definitions, please. Ensure that you get these 2 marks of these definitions. To say melting point is a temperature at which the solid phase and the liquid phase are at equilibrium. The solid phase and the liquid phase are at equilibrium. And then vapor pressure is another equilibrium again. But this one was saying is a pressure exerted by vapor at equilibrium with its liquid in a closed system. Remember, when we're defining melting point, we're not saying in a closed system, but when we're defining vapor pressure, we're saying in a closed system, because remember the molecules now, they have high kinetic energy, because for water to start to vaporize now, the water is beginning now to form those, it has more kinetic energy. So when we have higher kinetic energy, you know that the molecules can escape. I think you have seen it. Maybe you left the pot on the stove, and then when you come back, the pot is empty. There is no water because it has all vaporized and it became gas. So hence we are saying this one you must emphasize that when you define vapor pressure, you are saying it's the pressure exerted by vapor at equilibrium with its liquid in a closed system. So you are able to do that. Then you go to your last one, which is your boiling point. And then we're saying our boiling point is when we're saying that the vapor pressure now is equals to the temperature. Don't forget, you can't call it a point. If you say a point, already we have taken marks. You are saying it's a temperature. Boiling point is a temperature at which the vapor pressure is equals to the atmospheric pressure. So those two are now equal. So they are equal here. So it's equilibrium for melting point, equilibrium for vapor pressure, and equal sign for boiling point. Remember, if you are to write, this question was asked last year, to say learners must define boiling point, and learners wrote is a temperature at which the atmospheric pressure is equal to the vapor pressure. Unfortunately, that will be marked wrong, because it must be vapor pressure that is equal to the atmospheric pressure. So always you are starting with Vp equals to AP, not the other way around. So you got to always remember that. And if you look according to our exam guideline, these 3 physical properties, which is our melting point, boiling point, and vapor pressure, they depend on these these factors, which is your variables here, which I call if chain mob, so that you don't forget to say they depend on the type of intermolecular force. They depend on the functional group, to say if you have this functional group, definitely you will have this type of intermolecular force. They depend on the chain length. Like, for example, boiling point increases with increasing chain length. They depend on the molecular mass. Obviously, as the chain length increases, the molecular mass increases. So you got to understand. And they depend on the branches. You know, as you increase the branch, the strength of intermolecular force decreases, and the boiling point and the melting point will decrease, but the vapor pressure increases. Remember, when boiling point increases, vapor pressure decreases. So you have to have all that. So you can see that the strength of intermolecular force goes hand in hand with increasing boiling point and increasing melting point, whereas vapor pressure goes hand in hand with the decreasing strength. When the strength of intermolecular force decrease, the vapor pressure increase. So always have that in your mind, and it will help you. And we are saying as well here, as I indicated at the beginning of this lesson, to say we are having AAA, A and C. As we said, these 3, the hydrocarbons, they all have London forces, and the Hague, they have London forces and dipole. So you will refer to this as dipole, and you have your alcohol and carboxylic acid, your A and C there. Those 2, they have hydrogen bond. Don't forget, alcohols, they have 1 side of hydrogen bond. Carboxylic acid have 2 sides. So always when you're talking about alcohols, you will be able to know that it will form 1 hydrogen bond, whereas a carboxylic acid will form 2 hydrogen bonds, because it has 2 sides for hydrogen bonds. So it's always important that you always remind yourself about that. as we move. Now, you got to follow step number 1, for example, to say, let's look at what is different in the structure. What is different in the structure? You must be able, that is the first thing you will do, and then you have to state the effect of this factor to say what is the effect on intermolecular force. So you will say, for example, what is different is the intermolecular force. That is the first thing you'll say. Okay, we're having an alcohol and the aldehyde, they have different intermolecular forces. So you are able to say, okay, they have different intermolecular forces, then which one has a stronger intermolecular force? So what is the effect of that difference? And then you must always talk to the energy required to overcome the intermolecular force. So that is the 3 steps that you will always follow as and when you answer your questions, and it will always work for you to follow these steps as they are following one another like that. Now, let's look at questions now to say which one of the following compounds will have the lowest boiling point. Which one of the following compounds will have the lowest boiling point? So I've already indicated to you to say as the strength of intermolecular force increases, the boiling point increases. So you got to have that in your mind. So okay, this is butane. You know, butane, this is part of hydrocarbons. We said these ones have London forces, and London forces are the weakest intermolecular force. But if you look at butanol, they have London forces and dipole. So you know that these ones, they have dipole, so they are stronger than London forces. And then if you look at butan 1-ol, they have hydrogen bond, one side of hydrogen bond. So you must know that this one have hydrogen bond. So don't forget that, the types of intermolecular force that you get in each and every one of them. But look now, methyl propane. Methyl propane is a chain isomer of butane. So you know that once we have a branch, the strength of intermolecular force, this one is London force, but not only London force, it has London force and branch. That makes number D to have the weakest strength of intermolecular force. So that will have the lowest boiling point. Sure. So you see now, if you just looked at butane, you're going to choose butane, and it's not a correct answer, because the correct answer is D, because D has London force, and we are saying that it is branched. So the more we have branched, is the more the structure is becoming weaker. Which of the following compounds has the highest boiling point? This one, you just look at it already. You are able to see as the chain length increases, the strength of intermolecular force increases, hence the boiling point increases. So highest boiling point, it becomes D. The reason is that it has the longest chain, carbon chain. It has the longest chain length. Now, as we move, we're saying which one of the following sets of compounds shows the order of increasing strength of intermolecular force. So you see now what we are doing here, we're ensuring that you get used to dealing with questions, so that when you go to exam, already you have practiced as many problems as possible. So we were saying which one of the following compounds shows the order of increasing strength of intermolecular force. So there must be an order. Increasing, it means you are starting from lowest, we increase. So you are able to follow that. So sometimes you will say which one shows the order of decreasing strength, which means you are starting with the highest to the lowest. So always look at the keywords there, which is this way. In this one, the keyword is increasing strength. So we're starting from the lowest to the highest. Let's look at the first option, number A. You have chloroethane, you have ethane. You can see that already ethane is the lowest because of London forces. So you can see that here it's not increasing, because we're starting with chloroethane, which is higher than ethane. So it's out. Let's go to option number B. We're starting with ethanol. Ethanol has a hydrogen bond. It cannot be strong, it cannot be weaker compared to chloroethane. So we're supposed to start with the lowest. So this makes it wrong, because we're starting with hydrogen bond, and hydrogen bond is stronger than the London force found in ethane, for example. Now the lowest is ethane, we agree, followed by chloroethane, followed by ethanoic acid. Remember, ethanoic acid has 2 sides of hydrogen bond, so this cannot be correct. It must be ethanol, because ethanol has 1 side of hydrogen bond. So this one has 2 sides, is stronger, so there is no order there, which means the correct order is this one. We're saying London force, dipole. We're saying 1 side of hydrogen bonds, 2 sides of hydrogen bonds. So you are able to see that D is very much correct, and I hope it helps you as you continue to practice. Now, the question 4 is saying the relationship between boiling point and number of carbon atoms in a straight chain molecules of aldehydes, alkanes, and primary alcohol is investigated. Curves A, B, and C are obtained. So you have 3 curves there. You can see that as the number of carbons increasing from 3, 4, 5, 6, 7, 8, you can see that the boiling point is increasing as well. So that is good. Which compounds are represented by curve B? Now remember, they're saying one curve is aldehyde, one curve is alkane, one curve is an alcohol. So you can arrange them to say, okay, the weakest one is alkane, followed by aldehyde, because aldehyde has dipole-dipole, followed by alcohol, because alcohol has hydrogen bond. It's the strongest intermolecular force. So you can already see that C will be for alkane, and then B will be for aldehyde, C will be for alcohol. So you're able to do that and you are happy with no problem. Which one is B? B, you are saying is aldehyde. It's in the middle of these 3. So you know aldehyde, you just look for aldehyde and you're able to get your answer, which is number C there. Now, as we move further, now let's go to structured question. Let's do a structured question so that at least you know how to answer even the structured question. So we're saying 4 compounds of comparable molecular mass are used to investigate the effect of functional group. So we want to look at the effect of functional group on vapor pressure. Always remember that boiling point, melting point, they increase with the increase in the strength of intermolecular force. But when it comes to vapor pressure, when the strength increase, the vapor pressure decrease. That will always help you when you deal with this type of questions. We're saying which one of the compounds A, B, C, or D in the table has the, we're checking which one is the highest boiling point. You know that lowest vapor pressure means highest boiling point. And they're saying explain your answer. So you will be able to explain to say the compounds D has the lowest vapor pressure, which means it has the highest boiling point. So if it has the lowest vapor pressure, it means it has the highest boiling point, which means it has, you can even see ethanoic acid, it has 2 sides of hydrogen bond. It has strongest intermolecular force. Hence, we are going to say more energy will be required to overcome the intermolecular force of D compared with the other 3. So you are able to answer that question, and then you got your 2 marks. And then we move to the next question. Which one has the weakest intermolecular force? Remember, weakest intermolecular force means highest vapor pressure. So you know butane, it has only London force. This one, we said it has dipole-dipole. This one has 1 side of hydrogen bond. And ethanoic acid has 2 sides. So always look at that. You are able to answer your question, you say, and you don't have to say butane, you just say A. Weakest intermolecular force is A, because we know that A stands for butane. You are saving the ink as well. Now, as we move, refer to the type of intermolecular forces to explain the difference between the vapor pressure of compound A and compound B. Already, they told you here. Refer to the type of intermolecular force. So it makes the question much easier, because you are going to say, remember, I've gave you a skill to say you are told that A, butane is A, propan-2-one is B. So just refer to them as A and B. Then we're able to move forward with no problem. The other strategy that we can give you here is to say you answer this question in bullet form. Please don't write paragraphs. Don't write in paragraph form, because you lose the science in between. Just be straightforward and then say the first thing, I'm going to look for my intermolecular force in A. You know A is London force, because it's an alkane, it's London force. B is a ketone, they have London force and dipole. So it is dipole. Number 2, we are going to talk about the strength to say which one is stronger. So you know that the strength of intermolecular force in B, the strength of intermolecular force, you must write it in full. Intermolecular force is stronger here. This is a stronger intermolecular forces. B has stronger intermolecular forces than A. B has stronger intermolecular forces than A, and you are able to say more energy will be required. More energy will be required to overcome this stronger intermolecular force in B. So more energy will be required to overcome the intermolecular forces in B. then you got your 3 marks. You are rich. You take it with. So please always do that. And we're saying answer in bullet form. The first bullet, you are identifying the intermolecular forces of A and B. The second bullet, you are sticking to B to say, I want to talk about B. To say the strength of intermolecular force in B are stronger than the strength of intermolecular forces in A. From there, you talk about NH. So it's those 3 things. So I can say I there for you not to forget. You talked about the intermolecular forces of A and B. You compared the strength of intermolecular force, and then you compared the energy required to say which one more energy is required. If you are stronger, definitely more energy will be required. I hope you got that, and you'll utilize that one. That makes us to move now to organic reactions. We're moving to organic reactions. Maybe ask yourself to say, how many reactions do we do in terms of organic molecules? How many reactions do we do? Now, you know these acronyms that you must be able to remember. We are saying USA, which is your unsaturated forming saturated, that is your addition reaction. We are saying SU, which is your saturated forming unsaturated, is your elimination. We are saying triple S, which means when you have single bonds, remaining single bonds, that is substitution. So don't forget saturated, remaining saturated, substitution. And we are saying CEDS. Remember this, that when we have concentrated is elimination. You can have concentrated sodium hydroxide during elimination. You can use concentrated sodium hydroxide. Then you know that as long as we are using concentrated is elimination and heat. But now when you use dilute, you must know you can use dilute sodium hydroxide. We use it in what? In substitution. So if you want to substitute, you will use dilute. But when you want to eliminate, you will use concentrated. Because it's very much important as we start this section for you to remember that the reaction conditions are very much important, that you must know for each reaction, you must know the reaction conditions. I hope that helps you. Now, let's look at addition reactions, which are the first reactions that we are having. Remember, we are saying unsaturated. So immediately when you see a double bond, unsaturated, you know that what is going to happen now here is that unsaturated is going to become saturated. So that is addition, USA. So you know that our first acronym is USA, unsaturated. It will become saturated. As long as it's double bond, you know double bonds, they will become single bonds. So you know that it means as long as you are coming across those unsaturated hydrocarbons, you know that they will undergo addition reactions. We don't do other reactions for unsaturated hydrocarbons in grade 12. We do addition. So you know that when I say double bond, I know it must be, if you are starting from a double bond, it must become a single bond. And the reverse is the case for elimination. To say if we start with the saturated becoming unsaturated, that will be elimination. So you are able to see that when you move backward is elimination, when you go forward is addition. And then you are able to do that to say we do 4 types of addition reactions in grade 12, which is your hydrogenation. When you add hydrogens, I should have written them in a structural formula. You must show all the bonds. So you write it like that. That is, you always add at the double bond. So you will add one hydrogen there. You no longer have a double bond. Then you have that. You have done that. The same with the Br2. You must show the structural formula, which is Br bonded to Br. And then you are able to do that. The HBr as well, which is hydrohalogenation. You have HBr like that. And your water, I've emphasized that your water structure, you must know how to write the structural formula of water. Then you are able to add. So we do that. It's hydrogenation. And the reaction condition for hydrogenation, we're saying platinum, palladium, or nickel. And then for bromination or for halogenation, when we are adding those Br2, we don't use catalyst. So this is a spontaneous reaction that takes place. You add it like that. You will see when you do the testing of alkenes and all that, when we do use the bromine water there in order to see the addition reaction. So you're able to see that we have, these ones have reaction condition, hydrogenation. The bromination or the halogenation, we don't have reaction conditions. For HBr, this one, the reaction condition is that there must be no water present. There must be no water present when you're adding the HBr. And then when you add water, it goes with sulfuric acid. So you're able to know, we're saying this is hydrogenation, this is halogenation, this is hydrohalogenation, and that is hydration. I know by now you know them, and it's very much important that when you draw structural formula, you show all the bonds, even the bond between the O and the H. It must be able to be visible. Now, let's move. We move to elimination. Remember, I said when you have unsaturated becoming saturated, that is addition. But when you have saturated becoming unsaturated, that is elimination. And we only do 3 elimination, unlike additions. Remember, for addition, we added 4. We did halogenation there. We don't do dehalogenation. We do dehydrogenation. We can remove the hydrogens. That is through your cracking. And then we do the dehydrohalogenation when we are removing your water there, your hydrogen and your bromine. And then this is very much important that you remember this one, the hydrohalogenation, because you can see there are 3 products that are formed there. And that's when we are using concentrated sodium hydroxide to eliminate there. So we are able to form sodium bromide and water. So look, take care of that one, because if you look at our eliminations, this is the one that forms 3 products. And we are referring to this product as organic product and inorganic product. So we have organic products and inorganic products, 2 inorganic products and 1 organic product for dehydrohalogenation. And then dehydration, we are removing water. Remember, when you see water, you see sulfuric acid. So remember, reacting conditions where there is water, most likely sulfuric acid will help you there. Now we go to substitution, which is another type of reaction that we are having. You can see that for substitution, we start with saturated. Remember, we're saying triple S there. We're having saturated, which is our alkane, and then you bring Br2 there. And now that is halogenation. Because it's substitution, not all the Brs will substitute, only one. So the Br will take the position of the hydrogen, which this is hydrogen here. You can see the Br takes the position. From there, we go hydrolysis. We have 2 types of hydrolysis. We can use water and mild it, or we can use dilute. Don't forget, we said dilute sodium hydroxide and mild it. All of those 2 will be our hydrolysis, and hydrolysis product is our alcohol. And then we can bring back the halogen there by using HBr, and then we're able to have halogenation. So you can see that for substitution, we're having 2 halogenations and 2 hydrolysis. 2 halogenations and 2 hydrolysis. And I'm emphasizing on hydrolysis to say we use water and mild it, or dilute sodium hydroxide and mild it, because we'll always ask you about the conditions for these reactions. Now, questions as we move. Which one of the following is a product formed during the hydrolysis? We are saying of bromoethane, hydrolysis of bromoethane. You know that, okay, it's a bromoethane hydrolysis. We said we're using water, then we're forming an alcohol, then you're able to get it with no wasting of time. Let's move. When you do test for saturation, which one decolorizes bromine water? I talked about this one to say, okay, when you are having an alkene, you are able to add on the double bond, and you don't even need any catalyst. The reaction will just spontaneously take place. Consider the following reaction. This reaction is an example of, so you can see we are having a halo alkane is becoming an alcohol. So you know that we said when you use water or dilute sodium hydroxide and mild it, that will give us hydrolysis, which is a type of substitution. You know, hydration is addition. We only add when we have a double bond. Hydrogenation, we only do that in the addition. All these 3 reactions are addition reactions. So the only one that is substitution, because we are forming saturated, is forming another saturated. So you are able to see that triple S works here. That is substitution. Now, as we move, you are able now to have you will get a question like this one. So it's important that you are able to analyze the question. You are able to know when you see dilute sodium hydroxide, already you know that this must be substitution, triple S. Saturated, substitution. And then you are able to check what type of substitution. You know, dilute sodium hydroxide, we said it's for hydrolysis. So you are able to know that it's substitution. When you see concentrated, you know elimination. You're going to elimination. Obviously, you're going to eliminate a Br and an H. So that will be dehydrohalogenation. And you remember for dehydrohalogenation, we said we're able to form 3 products there, which is your alkene, which is your two inorganic products. Remember we said sodium bromide and water will be formed there. So as and when you do this, you are now able to enjoy. You can bring back the HBr there, which will be your hydrohalogenation addition reaction. Then you are able to do the entire reaction with no time. So you will continue to practice and understand. Another extract just to look at, to say, same as we were explaining, you are having an alcohol, you are having a haloalkane, you are having you know that this is substitution because you're having saturated becoming saturated, that is substitution. So you are able to see that immediately when you see concentrated, you know that a concentrated is bringing now about but you can see that we are going to have an ester here. It's an ester. So you can see that we had an alcohol, but we are forming an ester. How do we know it's an ester? The two oxygens now are within the structure, not at the end where there's a coup, because we said there are only two homologous series that have two oxygens. It's either esters or carboxylic acid. So you are able to look at that and be able to get that with no problem. For type reaction, for reaction 2, what type of reaction? So you're able to say, okay, the type of reaction already we said is substitution, formula of the inorganic product. You see, we are bringing HCl, we're putting the Cl, the halo is coming here, so we're taking the OH. So the inorganic product is water. So it's very much important for you to know that you are able to say the formula is H2, is H2O. But if we say the structural formula, you will draw it, the condensed structural formula of compound Q, you're able to draw the condensed structural formula of compound Q. How will you know the structure of compound Q? Obviously, you are helped here by this alcohol, because you see that this part is the part of the alcohol. Remember, so the alkyl part, which is 1, 2, 3. So you have 3 carbons there. You have 3 carbons there. Then it tells you the type of a haloalkane that you are having. You are having that. So you started with your alcohol, which was your OH there, and then you had something like that. This is alcohol P. When you started, you had alcohol P like that, and then we are saying now you brought in HCl, and then we said, okay, you are able to substitute the OH there. The OH comes out, the Cl takes the place, we are forming water. You are able to see that. Then we have the chloro. So you're just putting the Cl there to be able to draw compound Q. Now, let's move. Many questions that we can do on this type of reactions. Now, with no wasting of time, I would like to move now to chemical change. We are moving now to chemical change. You have done this part of energy and change in grade 11. So it is part of your revision, but it's examinable now in grade 12. Remember, you have done exothermic and endothermic graphs, these profiles of these reactions. Now you are able to see that we are having here the reactants that when they have enough. So the first thing that you will do, you are saying we have endothermic, exothermic, and endothermic reaction, and we are saying exothermic energy is released. Just take it from the word X is out, and the endo as in you're coming in, so the energy is what is absorbed. So you are able to see that endothermic will do that, and then you must be able to define the activation energy, the minimum energy required for a reaction to take place. You must be able to define activated complex, because we're saying this is a temporal phase or intermediary phase where all bonds are broken down and new bonds are formed. So many things are happening here. The activation energy takes the reactants here, so that the old bonds can be broken down and the new bonds can be formed. When that happens, it's either energy will be lost. You can see that when you say energy is lost, it means energy of the reactants is greater than energy of the product. Delta H is less than 0. When you say energy has been absorbed, the delta H is greater than 0. So you got to know that. You will remember as and when you move to question 6, you will be able to look at the forward reaction and the reverse reaction in that way, to say we must have activation energy of the forward reaction and activation energy of the reverse reaction. I've done this definitions to say activation energy is the minimum energy required for a reaction to take place. Activated complex was said is an unstable transition state where all bonds are broken down and new bonds are formed. It means we are moving from reactants to products. So we did that. the issue of collision theory to say for a reaction to take place, there are conditions that must be met. The first condition is that we must have enough kinetic energy. The second one is that we must have correct orientation. The reactants must be in correct orientation. Now we are going to look at the effect of increasing temperature on the rate of reaction. Remember, as you increase temperature, you are increasing the first thing. As you increase temperature, you are increasing the average kinetic energy of particles. Remember, in grade 10, you defined temperature as the measure of average kinetic energy. So that as you increase temperature, you increase the average kinetic energy. That is the first thing that we are saying. The second thing that we are saying we'll have more effective collision per unit time. So I can just simplify it, put like that, more effective collision per unit time. Don't forget that. And then when you do that, you'll increase the rate of friction. So you can see that with this graph, then the graph of T2, it touches. So you can see that the graph of temperature, you will always see that the two graphs must do what? Must touch one another. But if we talk about the one of concentration, it will be at the top there. So you can see that we increase the rate of reaction. So those are three bullets that you must never forget. To say as we increase temperature, we increase the average kinetic energy of particles, because we have particles here. And then we're saying more effective, you can write this, I'm just simplifying it for you, more effective collision per unit time, increase the rate of the reaction. So always know that the graph, it will shift like that and it will touch the other graph. I hope that helps you. Now, when it comes to effect of a catalyst, now with the catalyst, remember by definition, a catalyst, when you defined it in lower grades, when you're doing even enzymes, you said it's a physical property that speed up the rate of reaction. Now we are saying that a catalyst, it provides an alternate pathway of lower activation energy. So we're saying it provides an alternate pathway of lower activation energy. You see that the activation energy, the graph now moves inside, it goes in. So you can say that activation energy after catalyst, it's now lower. It just moves that side. You can see it moves to the left. So always for the catalyst, you will remember that. And then in terms of your bullets, the first thing we're saying, it provides an alternate path of lower activation energy, which is the first bullet there. Then we are saying the second bullet, more effective collision per unit time, and we'll have more particles that have sufficient energy and the reaction rate will increase. So that is our language. That's what we are saying in terms of a catalyst. I hope you know that and you are able to remember that as and when you write your exams. Now, with no any waste of time, we'll move with this one to say effect of a catalyst on a reaction. I've already indicated that this one is, it will lower the rate, the energy. So you can see that lowered. But now when you look at the graph of temperature, of concentration, you can see now it goes on top. It's now, because when you increase concentration, you are increasing the number of particles per unit volume. You are increasing the number of particles per unit volume as indicated there. Then you will have more effective collision per unit time. You will increase the rate of reaction. So please always remember these graphs, Maxwell-Boltzmann distribution curves, so that you are able to always remember these energy distribution curves, how they work. The same with surface area. We're saying when you increase surface area, you are increasing, more particles are exposed per unit time. More particles are exposed per unit time when you have increased surface area. And we are saying we'll have more effective. You can see that in all the statements, we are saying more effective collision per unit time. So you cannot talk about collision theory and without saying that. We're saying that will increase the rate of the reaction. So I hope that helps you as you move. You are able to do that. Let's look at just a few questions as we move to the end of our session. Say the rate of chemical reaction can be expressed in. Remember, rate of reaction, we said by definition itself, rate of reaction, what thing is the change in concentration, of reactants per unit time. The change in concentration of reactants per unit time, or change in concentration of product per unit time. So you don't forget the definition. Now, the other way you can say is the rate of change in the concentration of reactants. You can't write it like that. You must write it in what? In weights. Now, if you look here, there must be per unit time. As long as we talk about reaction rate, you see it's grams per mole. There is no per unit time there. Per mole, moles of product per liter of solution. The correct answer will be C, because it's volume of a gas formed per unit time. You can ask yourself, say you said concentration. It's not only the concentration. It can be change in concentration, can be change in volume, can be change in mass. So all those, we're able to utilize them to measure our rate of reaction. So always remember that we can do that differently. The rate of chemical reaction is mostly correctly defined as, you will have seen, we said is the change in the concentration of the reactants or products per unit time. That is the correct definition from our exam guideline. It defines it like that. So it's important that you always know that definition. I remember in 2023, we had a question in the final exam. We said is the change in concentration of products or reactants, is the rate of change in concentration of reactants or products per unit time. So we used rate and per unit time in one statement. You can't use them in one statement. If you say rate at the beginning of the statement, you can't say per unit time at the end. So please always remember that. Now we're saying the equation below represent the decomposition of calcium carbonate. So we're having calcium carbonate. Which one of the following factors will increase the initial rate? The initial is very much important that you underline that initial rate. Remember, pressure. Initially, when we start, we don't have carbon dioxide. So pressure is not a factor. It cannot affect, because it could only affect when we have product which is a gas. Remember, pressure affects only that one. But now if you look at temperature, yes, temperature is important. It can affect everything. Concentration is not a factor because we're talking about a solid here. We don't talk about concentration of a solid. We talk about concentration of aqueous solution and concentration of solids. I hope you are getting that, and it will help you. So it shows you that as we choose number B, then we are confident that it's a correct answer. Now, without any wasting of time, we'll move to the question, chemical equilibrium. The first thing that you must be able to remind yourself is that for us to reach equilibrium, it must be in a closed system and the reaction must be reversible. And you must be able to define what is closed system, what is reversible, and it's nicely stated in your exam guideline. We're saying this closed system does not interact with its environment, or is isolated from its environment. And we're saying a reversible reaction, we're saying products can be converted back to the reactants. You must be able to state the Line's principle. It's very much important that you are saying that when a closed system at equilibrium is disturbed, a new equilibrium will be reinstated. How? By favoring the reaction that opposes the disturbance. So please be able to state Le Chatelain's principle. You must be able to do the calculations of Kc, and we're saying Kc has no SI units. So you must be able to apply in terms of our grade 12. We don't talk about Kc with SI units, so you don't write any SI unit for Kc. You must be able to do stoichiometric calculations. You must be able to explain the meaning of Kc value. Remember, when Kc is less than 1, it means now we're having low yield. We have low yield. But when Kc is greater than 1, it means high yield. High yield simply means we have more products than reactants. So it's very much important for you to do that. We must be able to explain the shift of the chemical equilibrium. So all those as nicely indicated. Remember, when it comes to chemical equilibrium, we're saying for rate of reactions, it was affected by 6 factors. 6 factors affected the rate of reactions, namely, we will have said the temperature, we'll have said concentration, we'll have said surface area, we'll have said pressure, we'll have said nature of reactants, and concentration, catalyst and concentration. Yeah. So these are the 6 factors. So you got to have an understanding. We have 6 factors that affect the rate of reaction, but we have only 3 of those that affect chemical equilibrium. And those factors is concentration, pressure, and temperature. And we simply write them as Cape Town CPT: concentration, pressure, and temperature. Don't forget, I said the concentration is the concentration of gases and the concentration of aqueous solution. The pressure affects only gases, and then temperature will affect the rate of reaction, because we have said it increases the average kinetic energy of the particles, as we have done. So I hope you get that. As we look at some of the activities that we can look at to say which one of the following represent a homogeneous equation. Homo means same. So you just check, okay, we have a gas, we have a gas, we have a gas. That is homo. We have a solid and a gas, that is heterogeneous. So you see that this is heterogeneous. We have a gas, we have a liquid, that is heterogeneous. We have a solid and a gas, that is heterogeneous. So you see that A is our homogeneous equilibrium. So you are able to see that the difference between homogeneous equilibrium and then that you are able to do as many reactions as you can do. The balance equation for 3 reactions at equilibrium in a closed system are given below. You have all those in which reactions will the equilibrium position shift. I usually will say which one will in which direction will the equilibrium position shift when the volume of the reaction vessel is decreased. Remember, when you talk about volume, we're talking about pressure. So when you say volume of the reaction vessel is decreased, when you say volume is decreased, we are saying we're increasing pressure. So volume decrease means pressure is increased. And then if you look there, the equilibrium position when the volume of the reaction vessel is decreased at constant temperature. So you can see that here you have 2 and 1. Remember, when we talk about pressure, you look at then how many moles of a gas do we have. We have 2 in the reactants, 1 in the product. But when you look at this one, we have 4 and 4. So no effect, because the number of moles of a gas are equal. When the number of moles of a gas are equal, there is no effect of increasing pressure or decreasing pressure. Now, when you look at this one, we have 1 and 1 and 1 and 1. So it's 2 is to 2. So it's 4 is to 4. 4 reactants, 4 products, gas 2, 2. So it will only affect in 1, and your answer will be number A. Then you answer with no problems. And then you can continue to do as many problems as you can. Consider the equilibrium constant for the same reaction at 2 different temperatures below. So you can see that at a temperature of 298, and then you can see that Kc was 0.03. At 318, which means we have increased the temperature by 20 degrees. What happens to the Kc? It decreases. So if Kc decreases, it means reverse reaction is favored. And if we increase temperature and it favors reverse reaction, it will mean that reverse reaction is endothermic. So reverse reaction is endothermic, because increasing temperature always favor endothermic reaction. So you will know that, okay, what will happen is that the yield of the product, as the temperature increases, it must decrease. So our options is either D or B or C, because as we increase temperature, we're saying the Kc decrease, which means the reverse reaction is favored. Then you are able to check that, okay, heat of that reaction, the reverse reaction, it must be endothermic. Then we are able to choose option number C. It's a nice high order question, but we are able to respond to that. So you can do as many problems as possible. As I want to move as well, because we still have the very last small topic of acids and bases. But for structured question, just look at this question taken from June 2016 to say, what does the double arrow indicate? So you're able to answer that one to say that this reaction is reversible. Is this reaction exothermic or endothermic? Give a reason. So you're able to see that delta H is greater than 0. That is endothermic, because delta H is greater than 0. So you are able to respond to that question. How will the equilibrium concentration of the product compare to that of the reactant? Choose larger than, smaller than, or equal to. So my questions in terms of this, they are much simplified, because you have the answer there. Now, the last part, which is now the Kc part, to say, please don't forget how to go about calculating your Kc. We're given here, calculate the initial number of moles in CO2. If I can go back to you see the reaction there is CO2 gas plus C solid forming, so I must write it here. Sorry for that. Yeah, is CO2 gas plus C solid forming at equilibrium with, just bear with me, at equilibrium with 2CO. 2CO. So you're able to see, and then there's a gas. So this one is not a gas. So we are focusing on the gas. So you can see that what you do, you will indicate the reactants gases that you are having and the product gases that you are having, to say, okay, our reaction, even if you don't include this, is fine. Our reaction is between that and that. So you are able to check, okay, to say initially, usually I say rice, and then that rice must be cooked, so it's rice C. But you must tell us that the R stands for the ratio, because we want to see the ratio between these two, to say it is 1:2. It is 1:2. And you can say that initially we didn't have the carbon dioxide that we had, and then the product, it was 0 there. Then you are able as well to use the information to say calculate the initial amount of moles. My question is short somehow, and then it doesn't help our case. Now you are able to do that. The most important thing that I must emphasize on this question is that you will get mark for on the change there. The ratio must be 1:2, because we said the 1:2. So you will get mark for the ratio. You will get the mark for dividing by volume. So you can't leave the exam and you don't divide by volume. You will get a mark as well for subtracting on the reactants and for adding on the products. For writing correct Kc expression, please don't write Kc equals to concentration of products over concentration of reactants. You can't write that one as a reaction. You will write that correctly. Then you just substitute and you are able to get your answer. I hope you will calculate as many questions based on Kc as possible. The last section, as I close on this one, to say don't forget acids and bases. You have done that in grade 11. We must be able to define an acid in terms of Lorentz-Bronsted. Remember, with Lorentz-Bronsted, you said an acid is a proton donor, a base is a proton acceptor. And then we said, according to Arenas, we said an acid is a substance that produces hydrogen ion in water or in aqueous solution. A base produces hydroxyl ion in water or in aqueous solution. Now, a strong and weak acid. Remember, strong acid, we said it ionizes completely in water to give high concentration of hydronium ion. So it's important that you go to the exam guideline, you check weak, it will ionize incompletely. The same when it comes to the base. For the base, we're just changing the language there to say for the base, it dissociates. A strong base will dissociate completely in aqueous solution. A weak base will dissociate incompletely in aqueous solution to give a low concentration of hydroxide ion. Now, concentrated versus diluted. Remember, a concentrated doesn't mean weak or strong. Don't confuse them. When you say concentrated, we are simply saying, like from the C equals to N over V, we're saying it contains a large number of particles per unit volume. It contains a large number of particles per unit volume. That is concentrated. It means there is less water added onto it. But when you say dilute, it means it contains a less number of particles per unit volume of the solvent that is added there. And don't forget the difference between the monoprotic and the diprotic acid, where we have said the monoprotic acid, they can produce or they can donate 1 proton, but the diprotic, they can donate 2 protons. The triprotic or polyprotic can donate many protons. And you must be able to identify the acid base conjugate pairs. So now, as I conclude, I'll say which one of the following is the example of a strong acid. So you're able to know that strong acid, hydrochloric acid. So you know most these organic acids. These organic acids, they are not strong acids. They are weak, generally weak acids. According to Lorentz-Bronsted, an acid is remember Lorentz-Bronsted says a proton donor. So it's a substance that produces hydrogen and a substance that donates protons. So it's a proton donor. So you are able to do all those definitions, and you can do as many questions as you can. As I conclude with this question that says the equations below shows reactions occurring in hydrochloric acid and ethanoic acid solution. Both acids have a concentration of 1 mole per cubic decimeter and are kept at a temperature of 25 degrees Celsius. So what you must get to understand is that HCl is a strong acid, whereas ethanoic acid is a weak acid. So by definition, you have defined a strong acid to say it ionizes completely, but this other one, it ionizes incompletely. So you are able to answer, define an acid according to the Lorentz-Bronsted theory. You are able to say an acid is a proton donor. Write down one conjugate acid-base pair. So for conjugate acid, so you must be able to know that HCl is an acid, which that makes water the base, because the acid reacts with the base, and then the conjugate base of HCl is Cl minus. So the difference between an acid and its conjugate base is a hydrogen ion. So you're able to see that we have removed the hydrogen ion, hence we are only left with the Cl minus. So you will just write HCl and Cl minus as your pairs. Which one of the solutions, 1 or 2, will have a lower pH, value? You even if you don't look at you can look at the Ka value, or you can look at the acids themselves to say this one is a strong acid. Remember our strong acid, they are there around 1, 2, 3, the pH, lower pH. So which one between 1 and 2 will have a lower pH? You will know that this will be 1, which is your HCl. It has a lower pH because it's a strong acid. A strong acid, they have a lower pH. Or you can refer to the Ka value. You can see it has a very high Ka value, hence we are saying it's a stronger acid. So that's where I will leave this session. I hope you have enjoyed yourself. I hope you are well prepared and you are more confident to deal with these topics. Until we meet again, thank you.